So, not only am I here, my microphone's on, I am streaming, and we're going to start our lesson on learning about circle theorems. Welcome to my channel if you've not come before. If it's your first time, then I'm trying to use this time where we're all enforced at home to try and provide different topics, different skills. But if you're watching this 6 months down the line, it might be that we're all back at school by now, but this is hopefully still going to help you find out about circle theorems and find out what they are, how we use them, and why we use them. So without further ado, not that there was much ado anyway, with a little bit of ado, we're going to talk about circle theorems. We're going to be talking about what they are. We're going to be using them to derive more. Derive is where we use stuff you know to produce more stuff. We're going to talk about applying them, and then we're going to have a little bit of a challenge for you at the end. So, hello. Circle theorems. They were not invented. They were discovered after people did stuff with circles and went, oh, look at this. And that means, oh, look at this. And look at this. And it's all discoveries and things that have been worked out, rather than no one came along and went, I think I'm going to make this rule. For us to be able to use them, I'm going to need to teach them all to you. Now, the first few, I'm going to explain and going to draw on for them. I recommend either pausing the video while I'm doing it to copy them down, especially if you're here and it's not live, or going back and going over what they are, because I recommend you have a copy of all 8 of these in front of you to be able to use them. Excuse me. I've been sneezing a little bit today. Okay. With that, let's move into my special area of circle theorems and see what we've got. Here they are. 8 little circles. Now, you're not only going to need to be able to know what the rule is, you're going to need to know the name of them as well. You have to learn both, and so I'm going to try my best to make it as painless as possible. The first rule we're going to look at is the tangent rule. This is where you have a tangent touching the edge of the circle, and it says that a radius always meets a tangent at 90 degrees. It is called the tangent rule. No idea if this is going to work, but we will see how much it likes my writing. It kind of liked my writing. It just didn't recognise that was me, and it's made the tiny. I'm going to keep it that way. I think I quite like having a tiny e, but I think we want to make it nice and neat. So we've got the tangent rule. So the tangent rule says that a tangent will always meet a radius at right angles, at 90 degrees. The next one. This is where we have 2 points and we create angles on the edge of the circumference of the circle. There's one here and one here. What that says is if they come from the same point, and you can see here, this one comes from this point and this one comes from this point. If they come from the same point, then they must be the same angle as each other. That angle is equal to that angle there. Okay? We call this angles subtended. It's a new word from the same 2 points. I'm not sure it's going to like my writing here. I'll be very impressed if it can pick up that says angles subtended from the same 2 points. Well, there you go. I am super happy with that. Angles subtended from the same 2 points. Well, subtended just means made. So angles made from the same 2 points. We've now got a cyclic quadrilateral. I need to turn off this ink to shape. There it is. But if I create that like that, we create this thing called a cyclic quadrilateral. So it's any four-sided shape inside a circle is called a cyclic quadrilateral. The rule for cyclic quadrilaterals is that the opposite angles add up to 180. This rule is called cyclic quadrilaterals. Cyclic literally meaning within a circle. Hence cycle or bicycle. This is called the cyclic quadrilateral rule. Okay, so these are the first three rules. A lot of these rules come from each other, but we're needing to learn them all. The next one is if I make an angle to the middle and I make from the same 2 points an angle to the edge of the circle, we find something cool. We find that this angle and this angle, that one is 2 times whatever this is. So if this was 40, that would be 80. If this was 21, this would be 42. The angle in the middle is always double the one on the edge. Hence the name, double angle rule. Now I'm sure anyone who's trying to draw these will need a few seconds to catch up. So if you're doing this live, then I'm going to just check in the comments, see who's here. It might only be a couple of people. Willow, stop spamming the chat. A double angle rule. Hopefully you're keeping up with all this. Okay. And then we now have 4 more circles and 4 more rules. So we are nearly there. These are all the rules you're going to need to. This is a diameter. If you have a diameter, wherever you make an angle on the edge, it's always a right angle. Doesn't matter where on the edge you do it. I could do it here, look. That is also a right angle. We're using a diameter, and we call this angles in a semicircle. Next one involves 2 tangents. It's called the 2 tangent rule. There's one tangent. Now we already know from the tangent rule that that makes 90 and that makes 90. In fact, if you've got 2 tangents meeting at the same point, that line must be equal to that line. They must be the same length. So this must be a kite. Those 2 lines, there to there, must be the same length as each other. And that's called the 2 tangent rule. There's a lot of rules here, and I do understand it can get confusing. Please note, knowing 2 or 3 of these is often enough. That is not what I hope to do. So last 2, if you draw a chord somewhere on the edge, that chord, if I link it to the end with radii, 2 radiuses, it must make an isosceles triangle because that's R and R, which means if you then drop down the middle perpendicular, it will find the midpoint. Okay, and it's the rule is called bisecting a chord. Not sure my writing's neat enough for that. We will see. Bisecting a chord, and hopefully you're all keeping up with me if you're making notes. And the final one is the big one. It's like the big main one, and I'm going to do this in purple. We already know that if you've got a line that meets at right angles, but if I now add in a big triangle from that place, that big triangle, this angle here must equal this angle here, like on the other side, and this angle here equals that angle there. And we call this one, it's the one that's most important, the alternate segment theorem. Now, it's one thing being able to use these rules and know their names, but it's quite another being able to put them into actual questions and apply them. Because we've already covered this. They weren't invented, they were discovered, and we need to now know how to make sure we can complete questions involving them. We need to now be able to make sure that we can apply those rules almost like a detective to a problem mathematically. What I'm going to show you is how most people can get somewhere with these rules, but they throw marks away because it's not about just being able to use the rules. It's really important that you say what rule you used, and that's why I've gone through all the rules first. So going back here is something I prepared earlier. We've got all the rules. Let's scroll down a bit. Here is a question. This is what the questions will always look like. They will provide for you. They've got all the information you need, and they've marked on the angles. Just to clarify, A, B, C, D are points on a circle. A, B, C, D are points on a circle. PA is a tangent. PAD is 39. Angle BCD is 103. Everything's on there. What we have to do is select which rule is going to help us in working this out. There are lots of ways through this problem, but I'm going to show you a way. There will be others. First thing I've noticed is that this is a quadrilateral. So what I'm going to first of all do is say a dot cyclic quadrilateral rule. That's my explanation of why I'm about to do lateral. Cyclic quadrilateral tells us so DAB equals 77 degrees, and I'll write that in. So what I'm saying is, because that's 103 and that's a cyclic quadrilateral, we know from the rule, if we scroll up, the rule says cyclic quadrilateral is the opposite side. It would be the same on the other two opposite sides. Add up to 180. That's why that's 77. Does that help? Well, it does if I notice this. That angle there, from a tangent, must be, there's a triangle coming out here. Just going to identify the triangle, this triangle here. And the most common rule we talked about, the alternate segment theorem, says if you've got a triangle and a tangent meets it, this angle must be the same as the alternate side. That angle has to be equal to that angle there by the alternate segment. So I'm not going to get anywhere unless I write now by alternate segment theorem I now know that DBA equals 39 degrees. But the question says, what's ADB? ADB, ADB. So this is what I want. So my final reasoning, again, bullet point your reasoning. Angles in a triangle equal 180. Therefore, 77 and 39 makes 118, 16. Let's do proper maths. Therefore, the missing bit must be 64 degrees. So that must be 64, and I can write it in there as well. You can notice I listed one circle theorem, two circle theorems to get to that point. I hope it makes sense to people that you need to list your different circle theorems that you're using in order for this to work. It's very important that we realise that that's how you go about these sorts of questions. Listing your circle theorems. Then we listed a standard rule that we knew. That might be worth 4 marks, but we're not going to get them all just for that. You have to list your reasoning. This question breaks it down a little bit more. So this is now in different parts. We've got 2 different parts we're going to do to this question, and they're going to use different rules. So it's really important, if I can scroll up and get it nice and lined up so I can see everything. There we go. So for this one, I've got some information, and I want to first of all identify, if I want to do DAC, it's useful to me to do a little thing showing where DAC is. DAC is that one there. How can I work DAC out? Well, just so happens this point here and this point here make that angle there, but they also make this angle here. So whenever you've got 2 points that make the same angle, angles subtended from the same 2 points, we can say that they must be the same, it must be 55, and we say because angles subtended, remember that means created, subtended from the same 2 points are the same. Notice, I am a big believer in mark analysis. When you're doing a question, look at the marks. There are 2. You are therefore not getting a mark if you don't put your reason. Even if you knew it, you're not getting the mark without putting the reason. We're now going to do the next one, and you can't really do this on your exam, but it'll be a bigger sheet of exam, but I'm just going to delete everything we've done so far because I want to start afresh. But what I will put back in is the 55, because you can always use stuff you've worked out. This is interesting here because the next one, it says DCB. DCB. It wants all of that angle there. And the other thing we've got here, as well as angles starting from the same 2 points, is another quadrilateral. We've got a cyclic quadrilateral. And that tells us, so BAD plus BCD, that's not a plus, is 180. Therefore, if we know that that makes 95, 95 plus 85 is 180. So DCB must equal 85. Notice how I used a circle theorem rule, and in this one I used a circle theorem rule, and so that's how we can work them out. It's very important you treat it a bit like detective work. You take each question and go, right, which rules might apply here? There's nothing illegal or wrong with saying, well, this has got when you first see it, this has got a quadrilateral. This is also, there's no tangent. So that eliminates some rules. It's also got angles subtended. So it kind of, you can start listing possible rules before you even start the question. You can take the question apart and have a go at it. I'm not going to sit here and do question after question. I've done 20 minutes of teaching here, and I hope that's given you some understanding of what's going on. Okay? What I'm hoping is that if there are any people stuck, what they can now do is, if I go back to here, I can now go to here. What I'm hoping you can do is, if you have any questions and you're watching this video afterwards, which I know a lot of the higher tier do, from next week my higher tier lessons are unlikely to be live. I've noticed not many higher tier and A-level students want to use the live thing, and that's absolutely fine. What I'm going to do is make some videos, put them up and announce on the channel that they're now live, but that will allow me to make less errors with them. I can tidy them up, cut them a bit, make them a bit cleaner. So the higher tier and the A-level lessons are going to stop being live lessons because people aren't getting the benefit of interacting with me live. And doing it to 7 students is brilliant. I'm very pleased to have 7 of you here, but it's obviously more useful to do live lessons when there's lots of people live wanting to interact. And so I can now focus on producing nicer lessons for you that you can watch in your own time. So do look out for those, and any topics people want to do, put a message in the comments, send messages to me and ask me about them. I am obviously open for any questions. If you have questions, if you've got topics you want me to go through, please do ask me. If you have learnt something from this, please consider liking the video. Please do consider subscribing. I'll be adding more content, better content aimed for higher tier students. If you just let me know what topics you want covered, let me know what skills you want me to go through, and I'll happily do videos on that. I'm trying to keep you all amused during this difficult time. I know year 10s don't want to fall behind. Year 9s and year 8s want to push themselves forwards, and there'll be some year 11s who realise that learning this stuff is very important, especially if you want to go on to do A-level, but also we don't know quite what's going to happen with your GCSE calculations yet, and if you get the opportunity to do some stuff now which allows you to boost your grade, then that would be fantastic. We just don't know. Until we find out, why not do a bit more? I've been Mr. Harris. I hope you've enjoyed yourselves. I have, and thank you very much. I will leave you with my lovely theme tune to play you out.